Don't you hate when this happens to you?
Oh, where's the wheel? Where's the wheel? Oh my god!
Oh! And sometimes you just want to blast a tire into the air, and I'm not gonna judge. It's 2016, man.
Oh, where's the wheel? Where's the wheel? Oh my god!
Yeah. Where is the wheel? Oh, it's right there. But if it's not there, then what would you do?
Physics!
Okay, so let's figure out how high the tire goes. If we watch the video, we can see from the moment the tire is blasted up to when it touches the car, it takes 107 frames of video. The video plays at 24 frames per second, so that means the air time of the tire is 4.458 seconds. But that's the time for the tire to reach the peak height and back down. If we ignore the starting height of the tire and the height of the car and call this both 0, we can divide the time in half to get the time it took for the tire to fall from rest at the peak to the ground. So now we have some known values, a starting velocity of 0, a free fall time of 2.229 seconds, and because we live on Earth, we know that the acceleration due to gravity is 9.81 meters per second squared. So what can we do with all these values to find distance?
Physics!
All you need are some cinematics. All you need are some kinematics. And when you Google image kinematics, these formulas show up, so you know they have to be right. So the formula we will be using is displacement is equal to initial velocity times time plus 1/2 acceleration times time squared. So when we plug in our values and solve, we find that the tire must have had a maximum height at 24.347 meters. That is 15.112 Diana Halkias tall, which we can all agree is too much. But now we want to know how fast the tire is moving when it hits the ground. We can use another cinematic equation for that. Or we can use energy. Energy is conserved, but it's converted between gravitational potential energy and kinetic energy. At the top of its flight, the tire is no longer moving, so at that moment, the potential energy at that height is the total energy of the system. At the very bottom, the moment it collides with the car, there is 0 potential energy, and kinetic energy must equal the total energy of the system. Therefore, you can set maximum potential energy to maximum kinetic energy. When you set mass times acceleration of gravity and height equal to 1/2 mass velocity squared, the masses cancel out, so it doesn't matter how much the tire weighs. After plugging in our values, we find that the tire is moving at a speed of 13.446 Dianas per second,
otherwise known as 21.868 meters per second.
With these equations, you can pretty much figure out everything else about this tire's launch.
Physics!